Hi, welcome to the Open Security Summit session in January 2024, and we're going to have part 2 of the OWASP Wrong Secrets. We had a great introduction yesterday from Jeroen. The video's already online, by the way. And now we're going to have Jeroen and Ben talking about the OWASP Wrong Secrets and then define the future challenges together. So, guys, over to you.
Yeah, thanks a lot, Linus. So yesterday it was just Jeroen, now it's me and Jeroen. And whereas yesterday we looked more at what the Wrong Secrets project is, and Jeroen did kind of a show and tell there. We'll now try and see where we want to be heading, actually. There's a lot of challenges that we have already, and we want to progress from there. So hopefully with your help, we can now move Wrong Secrets forward. So very briefly, I'm a security engineer or consultant and a Wrong Secrets co-lead, do a lot of projects, utilities, telecom, etc., mostly focused on security engineering and the building side as well. Jeroen, if you want to introduce yourself as well, really briefly.
Yeah, for sure. Thanks. So I'm Jeroen Willemsen. I'm a principal security architect at a large firm. Also one of the Wrong Secrets leads. I've been mostly for Wrong Secrets focusing on developing the actual challenges and onboarding new folks and ideas.
Yeah, so we both merge a lot of dependent bot requests, I would say. That's the major one. And then we maintain a lot of the dependencies, generally speaking. And then there's a lot of challenges that we have built over the past few years. So we're really hoping to expand that from here. Very brief recap of OWASP Wrong Secrets, or rather yesterday's session, for those who haven't seen Wrong Secrets yet or need a quick refresher on what it is, what it does. So essentially, it's a vulnerable app and a secrets management testbed. So if you're developing some secrets management tooling, or rather detection tooling, say Trufflehog or Get Secrets or similar tooling, then you can use OWASP Wrong Secrets to check out and benchmark how many secrets it finds, and sort of give an independent score on how it does. The main goal is, though, to have it be an educational app. This is one of the first steps you would go to if you would want to learn well, secrets management and how not to do it. That's the idea, anyway. We also want to really help people reflect on their secrets management strategy. So often we see that secrets management really reflects how mature you are in terms of security engineering. A lot of breaches start off with a leaked secret. So from there, we want to promote secrets management as an important facet of security. And as such, where it can go wrong is an important topic. Let me see. Just adding some people to the room as well. Thanks for joining all. So for us to define some future challenges, it's important to understand how this app runs. If we look at the stack, then there is, first of all, the application code, of course, and the configuration that comes with it. This is mostly Java plus Spring Boot. So that's what the application runs. Then we also have some binaries in there, which are Go, C, C++, and Rust. Those are sort of standalone and built for the reverse engineering challenges. So the main application code is in Spring Boot or Java. Then we bundle it up into a container, Docker container mostly, which we can then run either independently or on top of something like Kubernetes. This also gives us the option to introduce HashiCorp Vault as a secrets management tool. And of course, for each of these components that I'm naming, we have or can have different challenges. So there are challenges related to Vault, there are challenges related to Kubernetes, there are challenges related to Docker, to Java, to all of these components here. Finally, we also allow this to be hosted in a public cloud. We provide the configuration files for the three major public clouds, so AWS, Azure, and GCP. Currently, that's it. And we not only provide this for just running an instance, but also for CTF mode. So if you would want to run this with hints disabled and really compete with your team or individually amongst each other, then you can deploy it in CTF mode and have fun. The important thing is, though, we are just two volunteers with a lot of extra contributors who are we're really glad to have as well. And without them, we really couldn't do as many things as we're doing now. We can build a lot, but definitely not everything. And every integration that we make is something that can break. So you need to bear in mind that everything should be able to be operated by us on a volunteering basis. So thinking of a new idea, it's important to also consider the maintainability. And we can't just integrate with all of the ticket management systems, for example. That would be a painful thing to even maintain for a project that you earn money on. And that's not something we have here. So ideally, things are simple, but do teach people to, well, do secrets management in a better way, or teach them how things shouldn't work, or maybe even how things improve. Like we also have some challenges that build on each other, where one layer is very bad, and then the next layer it's sort of kind of a bit better and more like how you would find it in a normal application. And then the layer on top is actually a pretty proper implementation, but then it has a role-based access control and misconfiguration, for example. So you can also think of these kinds of layers. I'll just give you a very quick run-through, and the public hosted version is freely available on wrongsecrets.herokuapp.com. So we can just go there really briefly. And what we see here is the user interface. And we're also looking at maybe modernizing this UI a bit. But for so far, it's functional, it's lean. And while we're not UI designers, it works so far. If you have any improvements or want to help or etc., you're more than welcome to. Let me put that out there. So looking at how this functions, we have the challenges, right? And you can look at the focus every challenge has, which is sort of where the secret topic is focused on. We have a difficulty we can sort on, and what kind of environment it relates to. So if we choose, for example, challenge number 3, is that actually over here now? Then we have the Docker env-based password, for example, and we can look at what's wrong. So why is it not a good idea to put things in a Docker env-based password? Well, it's pretty easy to detect these things, especially if you publish the image on Docker Hub, for example. And now I know the answer, but you could also, if you don't, click on Show Hints, and then we have a brief explanation of steps you could do to figure out what the secrets is. This can be disabled for CTF mode, so that participants will have to figure it out on their own, essentially. Now, how this works then is we find what it is. So we could go to like the Docker repository for this image. I already have it open here. And then we see the environment variables right here. And one of those is the Docker env password. So here we have, this is it. So putting your secrets in a Docker env is a really bad idea. especially if you're putting in a Docker hub, because it's plainly visible in the layers that you're building. That goes for more things that you're doing with a Docker container. So don't do that. And then building on this challenge, of course, there are more things that show how to do it properly, but maybe with another slight misconfiguration. So really briefly, that's what WrongSecrets does. We have a lot of different challenges here. So there's hard coding, there's front-end, client, infrastructure as code, role-based access control, secrets and binaries, sort of like the client one, right? There's some Web3 smart contracts related secrets in there. We have some accidental public exposures in issues or comments or on Reddit, for example. There's a GitHub workflow, so CI/CD, bash history. We have an LLM-based challenge. Stuff happening in logging, secrets manager misuse. Those are the things that we have right now. Now, thinking of new challenges, those can also be in the same space, right? Just maybe with a slightly different touch, like I was referring to before. Step one might be it's hard coding, and then that's bad, and then there's a proper way to do it, but then there's a role-based access control problem. Role-based access control can happen in a lot of different varieties. And what we're really looking for is scenarios that you might have encountered in daily life, in work, or heard of from some vendor or other software developer. Then we really want to get realistic scenarios. So we're not really looking for the typical CTF puzzle kind of scenarios, but really looking for things that are realistic. And yeah, that's some of the challenges we like most and would like to incorporate. That said, it is now time, and I hope that you, given the things that I've said, that you have a bit of a rough idea maybe on challenges that we could incorporate. And I'm really looking towards the chat here right now, and hopefully we can get some feedback from the audience on what kind of challenges it is that we should build, or what you would like to have us build. So just putting some pointers out there. What kind of challenges do you see in real life that we still miss or haven't properly addressed? Or maybe key improvements to the platform, or something else entirely. So feel free to post in the chat right now. Both Jeroen and I are monitoring the chat. And hopefully there are some people with great ideas. So Dinas is just making everybody co-host.
Thank you, Dennis.
All right. Yeah, so if anyone wants to speak up, now's the time. One of the challenges that I, for instance, would be thinking of was we have some AWS challenges, for example, or other clouds for that matter. And they all use a variant of key management service. And it can be a bit different in one than the other. And one of the things we don't have is role-based access control or IAM misconfiguration in there. So that's one of the notes that I would maybe make. We've also recently released 3 new vault challenges, or well, one is still in the release candidate rather, but 2 new vault challenges coming up. as an example. Is there any on the short list maybe for you, Jeroen? Or
I'm trying to think of something right now. Yeah, we were first thinking of maybe even including a mobile app, but that means maintaining a mobile app. So that was sort of off limits. Um,
yeah, so there's one thing we're looking at, for example, in the Kubernetes space, there are sealed secrets. It's a concept that's often used in combination with some kind of GitOps provider, be it Flux or Argo CD. So a challenge focused on sealed secrets would be one.
yeah, we could think of something maybe like a secret injected by some sort of script that we could use to instrument our nodes, like echoing a secret while applying salt to a Kubernetes cluster node, or echoing a secret while applying any other scripting language to build out the hosts at runtime, basically, maybe something like that. Just wondering for the other folks in the call, have you tried the project yet? Or is it completely new to you?
Can I see a one in the chat for people who used the project before? And the 0 if it's completely new to you. Make sure to hit, yeah, nice. Completely new. So some people for whom it's completely new. Interesting.
All right, instead of a brainstorm, would you all be interested for doing just a little bit more of a run through some secrets and as inspiration to maybe come up to with other secrets? Would it be interesting instead?
One in the chat if you agree. Who's up for some secret hacking? Press one in the chat if you agree. Just monitoring slightly. All right. So let's put it this way. We'll just run through some challenges. And let me put the link in the chat again so that you can participate with us and do some of these challenges and really learn. Before we go there, though, I really want to have some special thanks to all our contributors for, without whom this project would not have been what it is today. So thanks all. Just want to put that out there. So let me share the link. I have put it in the chat, so it's wrongsecrets.herokuapp.com. And from there, you see I already have solved challenge number 3. The first one would be the introduction, normally speaking, where there's some opening challenge, and this just explains sort of how to run it or learn it yourself. You can do that if you want to. So you can copy this command here and run it locally. This gives you the WrongSecrets desktop with some tools. And that will be exposed on localhost 3000. Now, this is not required for a lot of the challenges, but it's more, for example, if you really want some tools on the CLI for either reverse engineering or running through Git secrets, if you haven't installed that locally, then that's something you can use right out of the box. That will give you a web top, so to put it. So you can feel free to open that up. I won't. We can just go and start with challenge 1. So this first one is all about a centralized hard-coded password. And that's the most simple thing of a secret, actually, that can go wrong. Now, normally speaking, as you start out, you're programming and you write a proof of concept, and what do you do? You have a database or something, and or you need to talk to an API, and you put it in your code. All right, that can happen, and maybe it's kind of no problem if no one ever will see that secret. But as soon as you make it public, it will be visible for the world to see. That's one. And also, especially if you're an organization, it's really hard to tell who exactly has access to these kind of secrets. Secrets on your local file system, importantly, are often targeted by malware. If you do, for example, a pip install or an npm install, then what often happens, if you have a malicious package in there, they scan what is on your local file system for any kind of interesting secrets. So not necessarily only for centralized hard-coded passwords, but also .env files or AWS credentials files, or even Discord tokens, because those might be linked to credit card information. So malicious packages really are out there to try and steal the secrets that you as a potential developer or as an employee have access to, in order to pivot to other parts of the organization that might contain even more interesting secrets. As such, it's not a good idea to expose secrets to a wider audience than is necessarily required. And especially if you hard code it and it's actually being used somewhere, it's really hard to audit how that secret is used. And that's a quick rundown of the reasons why you shouldn't hard code this. So we have the WrongSecrets repo out there. So that's github.com/OWASP WrongSecrets. Let me put in the link in the chat again. And there, from here, there's a lot of files in there. And if you're new to sort of the Java structure, the Java source code in this project is in the source folder, and that's the starting point as to where to find the secret. Now we could just try and navigate manually finding this secret. That's one. Another one would be to try and use grep, for example. And sure, that's definitely possible. I can, however, already tell you that in this project, you are bound to find a lot of secrets with this kind of tooling by the nature of how we built this, of course. So you can sort of refine your grep skills here. And if you really can't find it, you can click on show hints. I'm just talking through this to give you some time to solve this. And for those who haven't really solved it by now, there's a interesting security advisory thing here. So Shrijit, if I'm pronouncing that correctly, has found a security advisory on GitHub. And that's not necessarily the answer to this challenge. It definitely is the answer to a challenge. So great job there. And that's, don't know if it's the answer by heart, but it's somewhere in the 30s, I think, ish. So just looking at this first one, when people write a proof of concept, they often start with hard-coded secrets, such as a password in code. And if we go to the source, then we have main, Java, challenges, and then it's in Docker. We have challenge 0 here and the first answer. We can look at challenge 1, and then we see there's some wrong secret constant.password. So where would this come from? This wrong secret constant. And now to get the security hat on, you often have to dive into a whole lot of different tooling or ecosystems or stacks, and it might be the first time that you're confronted with a Java project, with Docker, with Kubernetes, with AWS, with GCP, etc. So it's really important as you progress in the security space to be able to investigate where things come from. And this is like a Java construct or Spring construct, of course. And there is some class in this case that exposes this thing, this constant. So we could try and look at this. And indeed, we see the wrong secrets constant exported here as a public class. Default login password do not change. Let's make sure to get that exclamation mark out there as well. And sure enough, that's the correct answer. Now, you could just grab for password on the entire project, of course, and that would have gotten you there. And hopefully by the time I did this, a lot of you out there already had found it. So that's one. Let's move on to the next challenge. And if you have a specific challenge that maybe you saw in the UI, then by all means ask me and I'll try and complete this challenge, maybe make it a bit more interactive as well. Quick note, I won't give you the complete answer for all of the challenges, especially some of the more complicated challenges. And I think the reverse engineering one, for example, you really benefit a lot from trying and doing that yourself rather than me doing it for you. So, but I will be open to suggestions for challenges that I'll try and play next. Anyhow, let's progress with number 2 for now. Here we have a hard-coded password, but instead of putting it in the code, it's now in a configuration file. So in essence, it's still hard-coded. Like this is configuration is sort of data. And as such, it's often also committed to the repository, but it can also come from things like the environment that it's running in. It's slightly better than what it used to be, but still committing to the repository, probably not do this. So while it should probably be some kind of property or environment variable, maybe, instead, what's happening here, still being hard-coded-ish, but now in the config file, is a wrong thing. So application.properties, that's already what it says right here in the challenge. Where would this now be? Now, so it's a Java project still, right? So we have the source, and then we can go to main, and then we have resources. That's often where these things are. So we have a WrongSecrets configuration here, for example. We have index.html, some statics, some explanations for the challenges, and etc., etc. And we also have the application.properties, where we're looking at right now. So if we go through this file, we see a lot of different things. And some of these are legitimately used to configure the application, and some of these probably shouldn't be in there. And we see a nice password string right here. Again, doing a grep would have also gotten you this, and you could use something like trufflehog or get secrets alternatively. And these tools, they're kind of interesting in the sense that they also do Git history. So even if you've now found the problem and then removed it, you should still rotate this secret because it's in your Git history. And yeah, that's still visible. Git, by definition, incorporates the history of everything into what it is right now. So just removing it from the code is not enough. You also really need to rotate it. So there we go. We have now the hard-coded password part 2. So we've already done 3. Let's move on to challenge 4, where we have the Docker argument-based password. So it's not anymore in the configuration. It wasn't in the code anymore, right? It's also no longer in the Docker environment, or at least not directly. But it's now passed in as a Docker argument on container build. So this is something that the developer will specify the moment they do a build and push of the container. So the first thing we would always look at here is look at the Docker file, right? This is what defines the container. And in here, we see that there's an arg-based password. And we also see some kind of default here. So arg-based password default. We also see our other environment password, right? The one from challenge 3 that's already in here. Now we can try and run this. And you probably also know that this is probably not it, right? So they have indeed overridden this in the command line. It might also well have been the case that you forget to do this on build time. And as such, this default is still in there. Insecure defaults are, well, it wouldn't be the first time an organization would have tripped on an insecure default. So make sure you set these properly. And then this arg-based password, Now, if you think about Docker as a technology and how it builds images, what it does for every single one of these statements is build a layer, and these layers can be inspected. So we have already seen this in challenge 3, and to be fair, the same thing pretty much happens in challenge 4. As a layer, this thing is in here. So we have this arg-based password right here. This is on your command line. This is what the developer used to build the Docker container. Now, just inspecting it in Docker Hub is not always possible, of course, because that's not where all images necessarily live. But it's definitely possible to just use Docker history, for example, to look at a secret, look at the layers. So what if I open up my terminal? Let's open up iTerm. And then we can do, let me zoom in a bit, Docker history. And of course, I need to run Docker before this works. Yep, that's open. So let me try again. And here we also see this layer. So this is on your command line, etc. So that's another way of doing this. Potentially, if you have access to the repository or to the wherever it is that it's hosted, then you can deconstruct this. And we can also use the hints to see even more ways we could find this secret. Now, before I click the next one, let me quickly look at the chat if anyone else has a suggestion. So maybe look at the security advisory that Sergi mentioned before. That's challenge 35. So challenge 35. As we progress in a number of challenges, by the way, they don't necessarily relate to difficulty. It's just a new challenge. If you really want to sort by difficulty, then you can do so in the home screen and click on the difficulty tab. Some of these, by the way, if you're on a tablet or phone, you can pretty much do all the stuff that happens in the browser right there. So, or some of the web information-based challenges for those monitoring the chat, also really easy to do. It's a responsive website, so everything should align nicely as well on a phone. Where was I? The challenge 35. So, I received the link in chat from someone who found a secret, Sergi, right? And this is a hard-coded Google API key found. This is a security advisory that we as developers published. Now, unfortunately, it was a bit too open in that it actually stated the hard-coded key that allowed people to misuse it. And yeah, although it was patched, this key might still be valid, right? So let's try. There we go. So the lesson is being, if you publish security advisories, especially if they're public, don't disclose this, don't disclose these things too broadly, because they might contain things. Now, it's important to say the things that we have in here, these challenges, they're based on real world scenarios. So this is not some far-fetched story, and however stupid you might think something might be, odds are it's happened before and it's been the source of a leak. So just stating that. All right. I see no new suggestions for things that we can play. So maybe let's switch it up slightly. And instead of looking at some of the Docker or Kubernetes stuff, look at CI/CD instead. So what we have, for example, is challenge 13. That's related to CI/CD. And a lot of folks use some kind of CI/CD to build their projects, distribute them. And often these tooling also needs access to secrets to do its thing. For example, to push things to Docker Hub, you need to have an account or some kind of service account. And that is probably associated with some application key or other secret so that the pipeline can actually push the image, for example. Or you're pulling in something from a third-party API, and then again, you need a secret. So if you do that, then you need to make sure that these secrets are not exposed in some way. So essentially, especially if you open up the project to the world, but also if you open it up to your organization, potentially people could build new workflows or new CI jobs that access this secret. And I'm just filling the time right here so that you can discover this secret on your own, maybe. I'll start by giving a hint that the workflows, the workflow logs at least, are partially public for WrongSecrets, and that there's a workflow specifically for challenge 13. So if you look at GitHub Actions, then you might have already found it. But yeah, getting back to the story, if someone is able to make pull request or merge request, whatever the lingo is for your CI provider, it's important to note that they potentially have access to secrets, since they could just put any code in that workflow. And even though your provider might mask some of the logging to get it out there, essentially, as soon as you have the situation, you can consider your secret compromised. Now, why is that? It's often really trivial to bypass these things if you can control this in some way. And now I'm just going to the workflow. Let me first look at the code. So what's happening in the workflow? So GitHub workflows, and then we have challenge 13.yaml, which runs periodically. So what you could do as an attacker was to create a new workflow or alter the workflow such that it just dumps out the secret in the logs or posts it to a website. You could use, for example, webhook that site and do a curl post there, and you can see it there. And we know that the secret is called challenge 13 key. Well, by looking at the other workflows, you could potentially look at some of the other interesting secrets that are configured and then do something similar. But we could, if we just try to echo the challenge 13 key, we will see this will not work. Why not? Because GitHub detects that we have leaked a secret in the logs, and it will mask it. And even if we base64 encode it, so not encrypting, but encoding, just mentioning, even if we base64 encode it, it will still detect it. But if we do a double base64 encoding, we can spill the secret, no problem. if we now go to actions and we look at challenge 13, then indeed we will see for the first one that it is masked in the logging. And then for the second one, we have double base 64, base 64. We will see that there we have the secret. Now, the next thing we need to do is, of course, decode it again, because this is not the challenge solution. So echo yada yada. Oops. Let me get the new line out of there. And then do base 64 minus D, base 64 minus D for decoding. And there we have now something. Let's verify if this is correct. Boom. There we go. And that's how you look at things from challenge 13. Or exfiltrate things from CI/CD. And this will pretty much work across the board. So GitHub, GitLab, Jenkins, they can only do so much if you actively try and leak a secret. And well, I have yet to see a case where it was not possible once you had access to the CI to exfiltrate the secrets. So important place to secure. All right, let's do one final challenge. And I'm not sure if anyone has a suggestion. Maybe let's do a binary. Is that fun? A very simple one first. So let's pick the Go binary, for example. We have a different project. Let's see. For the binaries. And the binaries are actually hosted in the web application as well, or rather the build binaries. But for educational purposes, I'm going to switch this up slightly. So this is sort of a variation on the hard coding problem. And if you look at what's here, you can go to Golang. And Golang, yeah, if you're not familiar, there's often a main.go, which imports various packages, etc. This is a very simple one. And essentially, there is a hard-coded thing going on here as well. So we have command execute. Let me see, do I have the build binary? I think I don't have it at this moment. Anyhow, you can just run the binary and see if your thing is correct. But if you, let me see, was it in the, in the project, right, Jeroen?
Yeah, the binaries themselves are in the are compiled in the wrong secret resources directory. You only find the code of the binary right now in the binary project. And then resources, yeah.
There we go.
And then executables, there you'll find them. Awesome.
All right, so we go. And I'm currently on an M1 Mac, so we could just try and do this. And we could look at the help function. So wrong secrets, Golang RM, Guess test. Oops. Come on, not found. There we go. Incorrect. Try again. Next up, what we can do. So this sort of a variation on the hard-coded thing, right? We could fire up like fancy reverse engineering tools or whatever. But if it's hard-coded somewhere, especially if it's in a global variable and not nicely fuzzed or obfuscated, that's the correct word I was looking for, you could just provide a command called strings. And strings will list out all of the major strings that are in your application. So we could just do strings and then let me remove this. This is taking a while. Normally speaking, I would expect output straight away. Let's maybe try with a smaller one. C. So Go includes a whole garbage collector, a lot of other stuff. So going for the C one is probably easier. And we can see like this is correct, or we have the this is incorrect, try again, which we saw before. We see an error message, and we also see this is a hard-coded secret in C. So very simply, no reverse engineering tools, whatever, even if it's compiled into a binary, well, it's a matter of time before people found it. Same goes for building an app, distributing it. There we go. All right. That said, I'm getting back to the slides right now, and we'll just close it up. Again, a shout out, huge shout out to everyone who has contributed to the project before. Without them, this really wouldn't have been possible. So we're also really happy for you to have you contribute to our project. This can be anything from doing something in the UI, building a challenge, generating an idea simply, or working on documentation, anything really that can help us move the project along, you're welcome to do. We're happy to help you get set up in your development environment. You can join our Slack, OWASP Slack, open to use, and have a chat with us in the Project OneSecrets channel, or you can reach out to us via Twitter or LinkedIn or similar, and we'll be happy to help. So if you want to get started in open source, we're definitely welcoming for you to get set up. All right. Also, special thanks to some of our sponsors. We're not getting any money, but they do have us help use some of their tooling for free so that we can build some of the challenges, for example. And we also get some credits for running the infrastructure on a cloud provider, etc. So thanks to the sponsors as well. Again, we could really use your help. If you like WrongSecrets, promote it, give us a star on GitHub. That really helps. Take the project for a spin, give us some feedback, have your friends give us some feedback, or file an issue on or contact us in a OWASP GitHub discussion, whatever. And feel free to open a PR. Anything really would really help. So, that said, thanks for attending. Thanks a lot. And if you have any questions still remaining, I'll be happy to take them.
All right. Awesome walking through the session, through the challenges, Ben. Thank you so much. Thanks everybody for attending. If there are no more questions, then we'll close down this session. I hope you'll have a great time in the other sessions.
Yes, enjoy the Open Security Summit. By the way, you can always check out the recordings on YouTube. The other Wrong Secrets one is already out there, so by all means have a look. Cheers.
Cheers.